All right, let's look at the practice exam 2, problem number 5. All right, so let's look at part A. We want to find the first derivative and the critical numbers. All right, so let's do that. All right, so we want to find the f prime of x. All right, this is equal to. All right, so you can see that you have two things multiplied together. So here's the first guy right here. And here's the second guy. So we're going to use the product rule to take the derivative. Alright, so derivative of the first is 3 in front, quantity x minus 2, and subtract 1 from the power, so it's a second power. And derivative of the inside, derivative of x minus 2 is 1, so just multiply by 1. Alright, so that's the derivative of the first. And then multiply by the second, so we have x plus 1. Right? And plus, first guy is quantity x minus 2 cubed. Then multiply by derivative of the second guy. Derivative of x plus 1 is just 1. Right? Then we just have to clean up a little bit. Alright, so we have, let's see what's in common. So you have quantity x minus 2 squared. And it's actually, there are 3 of them here. So I'm going to just circle 3 just to remind myself that there's going to be another x minus 2 there. So if you pull those out, so pull this out and pull the same thing out from there. And we know that we're going to have, right, so you have x minus 2 squared. Right? Then we just need to, pick up the leftover factors. Right, so since 1 really doesn't do anything, so I'm going to circle this guy away. And also that one doesn't do anything. Right? From the first term, we have 3 is going to be distributed to x. So we're going to have 3x. Right? Then 3 also distributes to 1. So you're going to have 3. So plus 3 here. Right? And that's it from the first term. Second term, you're going to have plus x minus 2. Right? So we're going to have, we're going to add x and a minus 2. Right? Then we just have to clean up a little bit here. So first part is nice and clean. So quantity x minus 2 cubed. Right? Then we just have to collect the like terms. And you see that there's 3x here. And combine that with x. So you're going to get the 4x. Right? And then I'm going to combine 3 and the negative 2. And that's going to give you positive 1. Right? Right, so that's the first derivative. Simplified as much as possible. Right? Then we can find a critical number simply by setting the first derivative equal to 0. Right? So we get, set the x minus 2 equal to 0. So x equals 2 is one of them. And setting 4x plus 1 equal to 0, you can get the negative 1/4. Right? So those are the critical numbers. Right? So I'm going to just box them in here. So these are the critical numbers. Right? Got that. Alright, so let's move on to part B. We want to find the open interval where f is increasing and also the ones on decreasing. So you have, alright, so we have number line here. Right, and we're going to put 2 tick marks for critical numbers. Right, so I'm going to put the negative 1/4 here. It's a small number on the left and a larger number 2 on the right. Right, then we're interested in finding the sign of f prime. Right, so sample number, anything less than negative 1/4, I'm going to try negative 1. Anything between -1/4 and 2, I'm going to try x equals 0. Anything bigger than 2, I'm going to try x equals 3. Right? Then if you plug in -1, right, so into the derivative here, so we look at up here, right, since, oh, actually, I messed up one thing, right, here. This is not cubed, so that's squared, sorry. Right? Right, and here, since because it's squared, that's why I noticed the mistake, so it's going to be positive here. So it all depends on the sign of 4x plus 1. Right, if you plug in -1, -4 plus 1, so that's going to be negative. So we have a negative sign here. Right, if you plug in 0, 0 plus 1, so that's going to be positive here. And if you plug in 3, 12 plus 1, so that's going to be positive here. Right? So we know that the original function here is negative first derivative, so it's decreasing. Positive first derivative, increasing here. Positive first derivative, increasing here. Right? So we can say, so therefore, f is, right, increasing, so we're going to give an open interval, right, so it's increasing on, right, so you can see that it's starting from -1/4 and up, so it's going to be -1/4 to all the way to positive infinity. I'm going to put these two intervals together, and decreasing before -1/4, so decreasing on interval from negative infinity to positive infinity, right? So that is the intervals of increase and decrease, right? So that's the answer. Alright, so let's do part C. We want to take another derivative, so let's find the f double prime of x. So is equal to, alright, so derivative of the first guy, another product rule, so you have to put 2 in front, and then you have x minus 2 to the first power, I'm not going to write it, multiplied by the derivative inside, which is 1, times the second guy is 4x plus 1, just copy that, plus first guy, copy that, x minus 2 squared, multiplied by derivative of 4x plus 1 is just 4. Right? Here, I'm going to write 4 as 2 times 2. Right? 2 times, so I'm going to write 4 as 2 times 2. The reason is I have a 2 here, so I want to combine. So we're going to have 2 here. And I'm going to use one of these 2 here. And pull those guys out. So factor it out. So we have a 2. Right? There's another thing in common. There's x minus 2 here. There are actually 2 of them here. Right? So we're going to pull those out. So we have x minus 2. That's in common. Alright, multiply by 1 doesn't do anything. I'm going to circle that away. And we have 4x plus 1 from the first term. So I'm going to just put that in there. 4x plus 1. Alright, then we're going to have, there's going to be 2 times, I have to distribute to x. So it's going to be 2x. So we have plus 2x. And then we're going to distribute 2 to negative 2, so it's going to be negative 4. Right? Then if you clean it up, you're going to get this. This is going to be 2, and you have an x minus 2. Right, so we're going to combine. We have like terms, 4x and then 2x. So combine that, you have 6x, right? Then we have a 1 and a negative 4. Combine that, and we're going to have negative 3. Alright, so we can pull out 3. So you're going to have 6x minus 2, and then you're going to be 2x minus 1. Alright, so that's the second derivative. And then we want to find inflection point. So what you do is, it's similar to critical numbers. We set this guy equal to 0. Then we know that here, set x minus 2 equal to 0, so x equals 2. And set 2x minus 1 equals to 0, so you have 1/2. Right? Then we're going to do a number line here. Right? Then you have, so we're going to put a tick marks at the 1/2 and also 2. And we're going to have to make sure that there will be a concavity change. So we look at the sign of f double prime. So anything less than 1/2, I'm going to try 0. Between 1/2 and 2, I'm going to try 1. And the bigger than 2, I'm going to try 3. Right? Then if you plug in 0 here, so it's negative 2 and 0, negative 1. So 6 times negative, it's going to be positive. So you have a positive sign here. Alright, if you plug in 1, 1 minus 2 is negative. 2 minus 1 is going to be positive. So 6 is positive, x minus 2 is negative, and positive. So it's going to be a negative sign here. Alright? And then x equals 3, x minus 3 minus 2 is positive, 6 minus 1 is positive, everyone is positive, so you have a positive sign there. Alright, so we know that our original function is going to be positive second derivative, concave upward, negative second derivative, concave downward, positive second derivative, concave upward. So we know that there will be an inflection point right here because concavity is changing there. And then we have another inflection point there. Right? So all we have to do is find a corresponding y value. So if you plug in 1/2 into the original function, you get, let's see, 1/2 minus 2 is negative 3/2. You have to cube that, and 1/2 plus 1, so it's going to be 3/2. So this is going to be negative 3 to the 4th power is 81, and 2 to the 4th power is 16. Right? And when x equals 2, so f of 2 is equal to, plug in 2, it's going to be 0. Right? So we have inflection points. There are 2 of them. Right? First inflection point is it's a 1/2, comma. Right? Corresponding value is negative 81 over 16. And the second one is 2, 0. Right? So those are the inflection points. Alright, that's it. I hope that this was clear.